Hey guys, so today we're going to talk about the chain rule. I put in some chains there for fun. Chain rule. So we use the chain rule as a way to use differentiation when we have something different. We use this technique when we're differentiating composite functions. If you know what composite functions are, they are made up of layers of functions inside of other functions. Think mainly of when you see an expression like f of g of x, right? We have this outer function, we have an inner function, and then we have these two layers to it that we're going to have to differentiate them at different points. So an easy way to think about this is like an onion, like we can make this old Shrek joke about, ogres have layers just like onions, and we can talk about the layers of the onions, but it's applicable to the chain rule as well. So for instance, we know that if we have an onion, here's the outside, and we can peel it away, and then there's another part to it. And there's still more to peel, and we can keep going to it. The chain rule will help us if we have kind of a function inside of a function inside of a function, et cetera, et cetera, et cetera, et cetera. And it'll help us go all the way down to the core if we need to. So some functions may have many layers, some have, just two layers, and mainly we're going to be seeing stuff that only has about two layers. So you peel back one layer, you have that core. So So just think about it as we have like this outside, which would be your f, and your inside, which is your g. So it's kind of like f of g of x. That's the idea here, is that we're going to peel back those layers. So once again, we have f of g of x. That is our expression. So we got our inner side function, which is g, the outside, which is f. So how this works is essentially when you take the derivative of this, you're going to take the derivative of the outside function and multiply it by the derivative of the inside function. So it's kind of like f prime of g of x times g prime of x. Now, if you notice, the inside of g of x hasn't changed. So that's going to be a big part of this, is the fact that g of x is going to be kind of copied and pasted inside versus the outside of it will change. And then you're going to take the inside and take the derivative of that, and then multiply the two together. So here's how those steps go. 1, identify the inner and outer functions. 2, derive the outer function, leaving the inner function alone. Don't touch it. Then you're going to derive the inner function. So let's take a look at an example here. Here we have y equals x to the power 2 plus 1 in parentheses to the power 3. If you look at this, it should be pretty obvious that, hey, here's our inner function, our inside function here in yellow. The point of this is, do you remember, if the inside functions contain something other than just an x, you have to use the chain rule to find their derivative. If there's anything other than just x, it's going to be more complicated. In this case, it is more complicated. So that's why we have to use the chain rule. So if you look here, here's the outer function. We could think of this outer function as u to the power 3 versus the inner function will just be that u part. If we take the derivative of that, we would obviously get 3 to the power 2, or this 3 parentheses u to the power 2. So we're not really changing our inner function yet. So once again, let's take the inside function, which is x squared plus 1. And we're going to basically think about it as the inside function is u. That means that u is x squared plus 1, and the derivative of u then would just be 2x. So just keep in mind of that. We had that the outer function is 3 parentheses to the power 2. The inside function was going to be 2x. All right. So we have our outside function. What we're going to do is take the inside, take the derivative of the outside, which we said was 3 parentheses to the power 2, and we're going to copy and paste our inside function there, just like that. Bloop. So notice how we took the inside, copied, pasted, threw it in. Now you're probably wondering, hey, what do we have to do with that other part, that du part? Well, that comes afterwards. So we took the function, we took the inside, kept it the same, put it here. We took the derivative of the outside, which was 3 to the power 2, and then we took the derivative of the outside, which is just 2x, and put it on the outside. So that's how the chain rule works. Now, if we wanted to go further with this, we have the derivative of the outside, the derivative of the inside, the bloop. So we can obviously combine terms together if we want to. It's not always necessary to. For instance, if we take 3 times 2x, that would be 6x. And if we want to continue and just simplify everything, we can, but we're typically going to leave it here. We typically will not go further at the start of this. We're not that worried about simplifying it to its full extent. So let's take another example. Here, there's going to be some error involved here. So we have the first thing to do is identify your inner function. Here, it's this whole part here about 6x to the power 4 minus 2x to the power 2 plus 3. This is your inside. Your outside is going to be that power 1/3. So what happens here? Well, if you take the derivative of something to the power 1/3, you can get 1/3 something to the power of negative 2/3. Now, if you notice, we took the derivative of the inside and threw it on the inside. What's wrong with that? What was the mistake we made here? Well, remember, you're not supposed to change and put the derivative on the inside. You're supposed to keep the inside the same, right? You have to multiply the derivative of the inside function later. So here's what you're actually supposed to do. The first part was correct. We took the derivative of the outside, which is 1/3 parentheses power to the negative 2/3. Then we're going to copy and paste the inside. Blammo, like that. Then we take the derivative of the inside, which is a 6x to the power 4 minus 2x to the power 3 plus 3. The derivative of this would obviously be 24x to the power 3 minus 4x. Notice how the derivative of the inside is now on the outside being multiplied. So, and you can go further with this if you wanted to, but we can typically leave this as your answer. We don't need to simplify it or go further than what this is. And that's how we apply the chain rule. I mean, yes, we can go further, simplify it to whatever like degree or whatever satisfaction we want, but we're typically okay with how we had it before. So let's look at a different example. Here's another one. Let's look at, here. So here we had the square root. Now, remember, you're looking for your inner function, and if we have something like a square root, the inside function would be everything underneath the radical. So rather than working with a radical, it's better to deal with powers, rational powers instead. So instead of thinking of this as the square root of 3x squared minus x plus 1, we could think about it as parentheses of 3x squared minus x plus 1 to the power of 1/2. Now we've identified our inside. Let's take the derivative of the outside function. The derivative of anything to the power of 1/2 is going to be 1/2 to the power of negative 1/2. Then we'll take our inside and just copy and paste it in. Boop, like that. The last step is to take the derivative of the inside. The derivative of 3x squared minus x is going to be 6x minus 1. And we put that on the outside. And here, we're pretty much done. We can go further with it, but we're fine leaving it like this in terms of this expression. And that's how we apply the chain rule. It's a function inside of a function. It's like the layers of an onion. Now, for today's activity, what we're going to do is that we are going to have an around the room activity that's going to involve Marvel Avengers. So this activity is called Who Beat Thanos? So it's the final battle and the dust clears away. Thanos, the killer titan, lays defeated. All the Avengers fought hard, but only one. Nobody could tell who laid the final blow on the supervillain. All the Avengers want to take credit, but only one way to find out is with mathematics. Around the room are problems and answers. Once you solve a problem, find its answer and scratch off that superhero from the list below. The last remaining hero is the one who gets the glory for defeating Thanos. So, around the room, I'm going to have various problems, and you're going to see all of the different Avengers. I have all the famous ones like Iron Man, Thor, Captain Marvel, and of course everyone's favorite, which is Squirrel Girl. You don't know Squirrel Girl? She's pretty popular. But so, you're going to see all of them out there. You will also see various problems like these, and I'm going to ask you to find the chain rule. Use the chain rule to find your solution. So here will be various problems that you're going to have to apply the chain rule to. Then, once you have done that, you will find the answer of the Avenger next to an answer. If that is your answer, you'll cross them off. So it's going to be the process of elimination. Once you have found all of the answers to all the problems, the remaining Avenger is the one who actually defeated Thanos. So it could be anyone. It's not based canonically by the movie or comics. So you're just going to have to try to do it. Now, I want you guys to work in groups. You can have a partner, and the two of you can go around and write your answers in these boxes here so that we can keep track of which answers you got, which ones you don't. But so all of those will be around the room, and if you have questions, I'm right here to help.